Okay, here's what we have. Okay, we're talking about area and volume, surface area I should say, and volume. Today, my goal is to do a couple of the problems you had in your homework so that you actually understand how to do them. I have one picked up for sure, and then I'll give you another option if you'd like to pick up another one. The one I'd like to start with today is number 21. I want to start with 21. So if you haven't seen this problem yet, maybe you haven't got there in your homework. We had homework, we had page 70, that was the thing I assigned you yesterday. Due this Friday, so you have a couple days to work on it. We will have one more not book assignment, but we will have one more assignment this week, but it's an assignment we'll do in class together. So you get some easy points for it. So kind of warned you of that earlier. So, but for page 70, this is number 21. It was a problem that looked like a right triangle, and then it was going this way. So it almost looked like a block of cheese, if you can kind of see that. It's like three-dimensional cheese going to the back. All right, now, I believe they did not ask for the name of the object. They don't do that. There's a couple problems that they do. They ask, what is the name, classify this object, figure out what type of polyhedra it is, and then go from there. This problem is not one of those. It is a problem where it asks for surface area and volume. And the problem is knowing how to actually calculate it. Because if you look at my list here, what type is it? Out of the 4 or 5 that I have up there. It's a prism. It's a triangular prism, not a pyramid. Question?
Do you have to color coordinate your markers?
Always.
Your OCD?
Always, yeah.
I've noticed that too.
Alright. Now, yeah, it's a pet peeve. So, same with like desks, having like nice clean rows. Alright, so the idea is that we have to calculate the actual surface area, but it is a prism. In fact, it's a triangular prism. The bases are actually triangles. How I know that? The two walls that are parallel to each other, that's the front and the back, those are triangles. So that's how you name them, right? It's normally, usually when you see a triangle prism, they have it sitting on the triangle at the bottom. This one is the front and the back are the actual triangles. So it kind of looks like a tent almost, a lean-to. Now, the numbers that they give you on your problem, they say this is 8 centimeters, this is 6 centimeters, this is 5 centimeters, and this is 10 centimeters. Those are the numbers they give you at number 21. Now, the 6 and 8 can be switched, it really doesn't make a difference. So, all right. Now, here's what we have to do. First step, we have to calculate surface area. Surface area, if you don't know, it's like the faces of each part of this picture, like every wall, has a surface to it, right? We have to find the area of that surface. That's like, if you look at the floor, it's how many tiles are on the floor. So if you're imagining you're going to color this in paint, paint it, or you're going to put wallpaper on it, it's how much wallpaper would actually cover the surface. That's area, that's surface area. And so the idea is that I have to actually add up all these areas. So I'm going to do the triangle first, the front triangle, it's a right triangle. Then I'm going to do the back triangle, because what do I know about the front and the back?
Parallel.
They're exactly the same and they're parallel. They're exactly the same picture, the front and the back. So once I have the area of the front, I know the back one. Now the other 3 walls I have to do is this kind of leaning side here. I have to find that area, that is a rectangle. There is one on the bottom, which is, it's a rectangle, it kind of looks the same. It is a different dimension than this wall. It has different side lengths. And then there's a wall on this side, which also has different side lengths. Okay, does that make sense, what we're doing? Okay, we're gonna do each of those and then add them all up. That's surface area. So I'm gonna give you a kind of a freebie here, so let's do surface area. Now I'm gonna do this in a couple different ways, because I know the book has this crazy formula you could use. I don't like to use that formula. I like to just think about it common sense. Now, to do this, to find every area of the shape separately, because that's how I do it. I don't use this crazy formula that they have. This is the formula you should be using. When you do area, you should do area formulas, like triangles and rectangles and circles. That's what I look at. That's how I do this in my head. So, let's just do the front. Let's do this front triangle. What are the dimensions of this triangle, like length and width, or base and height? 6 and 8. Those are my numbers. That's by base. That's how tall the triangle is. It's a perfect right triangle. So, to find the area of that triangle there, I'm doing the 6 times the 8. So 6 times 8. And then the trick is you have to cut that number in half. That's the area formula for in fact, I have that highlighted right there. That's really nice. It's highlighted. Okay, and then a little box around it. So half the base times height. So now if I multiply this, that's 6 times 8 is 48. and I cut it in half, that's 24 centimeters squared. Okay, does that make sense? Now, what would the back triangle be? 24 again, yeah. So, now, this is just a visual aid to help you out. 24 centimeters squared. 24 centimeters squared. I'm keeping track of all the different walls. So far, I have 2 walls accounted for. Does that make sense how I calculated it? Okay, now let's do the other walls now. All right, so the other wall here. This other wall is a rectangle. What's the dimensions of that rectangle? What's this rectangle? What's the length and width of it? 5 and 10. Those are the numbers I have to multiply. So that rectangle is 10 and 5. I multiply those together. Because if you look over there at the formula to find area, it's just length times width. You can see it over there, L times W. Length times width, that's what, 50? So that first rectangle is 50 centimeters squared. I'm keeping a running tab of all the different areas. Okay, let's do the bottom now. The bottom of this object is also a rectangle. It's the floor of my tent. What's the dimensions of it, length and width? 6 and 5. It's 6 this way, 5 deep. So when I multiply those, so that rectangle there is 30 centimeters squared. That's 6 times 5. That's the bottom. Does that make sense? And then the other wall would be this wall in the back. This wall over here. It's 8 and 5. It's 8 tall, it's 5 deep. How I know it's 5 deep? This number and this number are the same. So if I multiply that, that rectangle is 40 centimeters. Then the last step is I just add straight down. So if I add straight down, add these all up, I know I'm going to end up with 8. 4 and 4, that's what? 4, that's 8. What is that? That's what? Let's see, 9 and 8, is that 178? If I did that right in my head, I can't add it, seriously, I can multiply it.
I think it's 68.
68.
68? No, I can't add, I swear. It's terrible, it's embarrassing, can't do it. So 24, 24, 50, 30, and 40. 168, there you go. All right, questions on the surface areas. So that's every face, like, add up. I know the book has that crazy, I don't even have it up anymore. The book has this crazy formula to find surface area, where you use you use the perimeter of the base, you take it times height, you add it to 2 of the bases, add it together. That's this crazy formula. I just think of it like if you're doing a prism, just find each face separately. And you just have to worry about, okay, I'm doing a triangle, I'm doing a rectangle. If you keep it that way, it's a lot easier. It really is. Questions though? Perfect. All right, now, I'll give you guys kind of an option, because that was 21. Oh wait, we still got to do volume, don't we? Volume. Now, volume on the other hand, I do the formula that I have on the board. It is actually the easiest formula that we have for volume of any type of prism. It's the formula I just strictly use. There's no other easy way to do it. You take the base of your picture. Now in this case, the base of this, triangular prism is the actual triangle. I know it's not sitting on it, but when you name an object, it's whatever the 2 walls that are parallel to each other. So in this case, the 2 walls that are parallel are the triangles. So it is a triangular prism. So I have to find the area of this triangle, that's what this is saying. And the area of the base, that's the triangle, and then take it times the height of it. So really, if I drew it on its side, like that, and it was going straight up, where this is the plate that it sits on, that should make more sense. Now, how do I find the area of this triangle? What do I have to do again? What's the number? Okay. Base times height, and then cut it in half, right? That's the area of the base. That's the area of the triangle. This turns out to be 24 centimeters squared again. Okay, that was the dimensions. That's the area. Now that's this value right here. That's the area of the base. How tall is it? What's this number? It's 5. It's 5 in like depth. In terms of height, it's 5. So I'm gonna have to take that times 5. 5 centimeters. Because that's how deep it is. This is 6 by 8, and then it's 5 in height when you actually stand it on its end. So 24 times 5, that is 144. No, 100. It's a 120 actually. 120 centimeters cubed. And it's cube, right? When you do a volume, it's 3-dimensional. It's like how many like sugar cubes or bales can fit in there is 3-dimensional. Area is 2. Wall, 2 dimensions. That's how I remember the labels. Okay, questions with 21. That makes sense like how I did it. You really have to know the base though. You need to calculate the area of the base, take it times how tall it is. All right, so that was 21. Now, is there another question that maybe you got to at some point? Because you're probably not done yet, and that's what I'm expecting. But maybe you got to a certain problem and you're like, I'm stuck, I don't know how to do it. Fire away. 5, okay. Let's look at number 5. We'll walk through it and hopefully this will make sense to you. Okay, so number 5. Okay, so this is the one, it's talking about a cone shaped. It's got a certain diameter, it's got a certain height, and it's got a slant. So, do you have the numbers in front of you? Do you have like them written down? Okay. Here, I'll just give you, I don't want to use my book. I'm on a subsheet. 6.5 inch, 6.8. Okay. Okay, so here's number 5. Let's walk through. Okay, I've got the formulas on the board. Perfect. Okay, same question, right? It's going to ask for surface area, it's going to ask for volume, and we got a new picture now. Alright, so, and I'm going to strictly use the formula that's on the board, because when you get to like the cylinder, cone, and sphere, I just use those formulas. Cool. So those are the 2 I'm going to use. Now, let's go to the numbers here. Here's what we got. We have a cone. Okay, now they're saying the diameter of the cone, well, it says diameter, not radius. Yeah, it says diameter is 4 inches. That's this number. That is 4 inches. Now, that's the diameter. It's straight across the circle. What number do I need?
The radius.
The radius. So how do I find radius?
Half of the diameter.
Half of it. This is diameter. It's all the way across. I need to cut that in half. So that means my radius is 2 inches. Does that make sense? I do need that number because if you actually look at all the cone stuff, you look at all the formulas I'm going to use, I use radius, R's, the radius of the circle. I know the height. They told me the height of this object going straight down through the middle of the cone. From the middle of the cone straight down to the point, that is 6.5 inches. That's height. And then we have a slanted line. That's like the side of your cone. That's like the actual piece of the cone itself, the actual part you hold on to. That slanted line is 6.8 inches. Okay, questions with that so far? Okay, so we got all our dimensions here. We got everything we need. We're going to use them together into the formulas I have over there and spit out the single numbers. Now this is where if you have a calculator, it'd be really handy, so I can ask you to do some calculations for me. Now when we use pi, I'm just going to go 3.14. Just 2 decimal places, don't go past that. I know a lot of you have really nice calculators. You actually have like a pi button. Just type in 3.14, just go like 2 decimals. We don't need to go very far, much farther than that. All right, let's do surface area first. Again, this is number 5, by the way. All right, so surface area. Okay, so surface area, you can see the formula, that crazy formula over there. Pi r L plus pi r squared. Okay, now what this formula represents, just so you know, this is the curved body. That's like the surface of the curved handle. This is the circle at the top of the actual cone. So imagine the cone actually had like a lid on it. That's what those represent. How I know that pi r squared is the formula for a circle. That's how I know it. Okay, so what we're going to do is we're going to plug these numbers in. Now what these represent, pi is obviously 3.14. I'm just going to go 2 decimal places. I don't need to go much more than that. I'm going to take that times the radius. What's the radius of my circle? 2 inches. 2 inches. Now we're going to take that times the L. L is, according to this chart over there, it's the slanted line. It's the slant. So that's what? 6.8 inches. Okay, do we understand that? That's the first part. That's this part right here. We're going to multiply those 3 numbers together. Then we're going to add it to the next part. Pi, which is 3.14, times the radius squared. Well, my radius is 2 inches, and we're going to square it. These are the 2 parts I have to calculate, and I'm going to add the 2 numbers together. Now, can somebody do the top number for me? Can somebody take 3.14 times 2, and then times 6.8, and tell me what that number is?
42.704.
42.704. Okay. And that's in inches, so that's inches squared. Okay? And somebody do the bottom one. 2 squared is 4, so just ignore that. This is 4, 2 squared. 2 to the second power is 2 times 2. Right, so that's 4 times 3.14.
12.56.
12.56. That's inches squared. Okay, do we feel comfortable with where the 2 numbers come from? Add them together. What do we get?
55.264.
55.264?
Yep.
Boom, that's inches squared there. Boom. That's surface area. So if I was going to paint it or put wallpaper on it, that's the idea. That's the surface. It's how many tiles, square tiles, fit on the surface. You know, a tile of the object. Okay, second part. It says find volume. How much objects could I fit inside the cone itself? So now we have to use the different numbers. So I have a new formula over there. Volume of a cone. Volume of a cone is 1/3 pi r squared times height. So height is that object going right down through the middle of my cone. So in my case, 1/3 times 3.14 times the r, which in my case is 2 inches. We're going to square that, which is 4. And then take it times the height. What's my height? 6.5. Okay, so now how I would do this, if I was typing this in a calculator, 6.5 times 4, this is the number 4, 2 squared, times 3.14, and then since I got to a fraction, I just divide by 3, right? Or it's the same thing as taking this number times 1, divide by 3. That's the way I can type it. I do need to know that number. Say it?
27.213 GD.
3 repeating, and that's in inches cubed. So again, how we did that, 6.5 times 4. So if I just show you the numbers, so it's 6.5 times 4 is 26. Then I take times 3.14, which is 81, and then we have to divide by 3, which is that number. All right, questions with how to find volume? That'll help you out a little bit. Now notice the labels. Surface area is squared, volume is cubed. That's just how I know my labels. Okay, I'm going to give you the rest of the time today, about 15-20 minutes. You can just kind of work. You can move around the room. I do want to give you, this would be probably one of the only days you actually get time in class to actually work on this assignment. I'm going to make sure that the website, the videos connected to the website so you can watch it. Just have to make sure they're published together. But yeah, so you can work on this. We'll have one more assignment this week. That'll be on probably tomorrow, but we're going to do it in class together. So you get some easy points that was turned in for the end of class. But
When is our next test?
next test, next possible day where we'll take like maybe a quiz, maybe the end of next week. That'd be the earliest I would do something. Major test, 2 weeks from now, something like that? Because we still got we have a few sections to go through. I think we have like 3 sections to go through chapter 2. So, a lot of algebra that we're doing this chapter, a lot of calculations, solving for x, solving for y, names. Now, next week, Tuesday, I'm kind of warning you of this. Tuesday next week, I have a meeting on Tuesday afternoon. It's for the school, it's for the position, my model teacher position. So Tuesday, potentially next week, I will not be in class. You'll probably see me in the morning, I'll be here all day, but I have a meeting in another room, so you'll probably have a sub that afternoon on Tuesday next week. I don't know if it's this period or period 7, they haven't really told me what period I'm in, where I have the meeting. So you'll have a sub, probably you'll just have work time to work on an assignment. You'll probably get an assignment that day, and you just get to kind of work on it. We'll do all the notes leading up through Monday. So. All right, questions at all? Okay, perfect. So just kind of giving a heads up that I'll be gone next Tuesday in this class.